Hello, my name is Johnny Onstein, and welcome to my video explanation on what the empirical rule is. Sorry. Alright, let's go ahead and get started. So, with the definition of what the empirical rule is, it's basically the empirical rule. It helps us understand how data is spread in a normal curve. When we have our values, most of those values are close to our mean, and in that case, in our case, I should say, our mean is 75. So that should be our middle. Ignore how terribly spaced out my graph is. I'm doing this on mouse and keyboard, so just kind of ignore that. So the empirical rule states that about 68% of our data will fall between one standard deviation or one standard area, while 95 within two areas, and then 95% within, 99.7 between three of the mean. So 3 away from the mean. So in this example that we have up here, we have 75 as our mean and then 10 as our standard deviation. So let's go ahead and start off kind of plotting our curve. So the type of curve that we're going to be using is a bell curve, and that is going to act as our normal curve. So let's go ahead and just change colors really quickly. Bada bing, bada boom. Oops. So basically, we're going to start right nice and simple. We're going to start at 0, 0, at 45, and then slowly but surely kind of gradual up to our peak at about 40 or 0.040. And then we're going to come right back on down when we hit the 105, right back at 0.00. Hopefully that makes sense. Okay, so now that we kind of have our graph here, we're going to go ahead and highlight the different areas, right? So as it's stated in the empirical rule, 68% of our data is going to fall between 65 and 85. So this beautiful area right here. And then if we change colors again, we're going to go to yellow. 95% of our data is going to fall in between 55 and 95. So every single time our gap is getting bigger and bigger and bigger, right? And then finally, our 99.7% of the data falls between good old 45% to 105%. So it makes it kind of sorbet color, right? This means that our values outside this range are extremely rare in normal. So anything outside of this is extremely rare in a normal atmosphere, right? So now let's go ahead and think about a more realistic, or something that we would actually find out in the wild, right? Like in real life, a relatable scenario, I guess. Let's say there are, well, we're just going to keep these numbers, right? Because these are the numbers that we have. Might as well make it simple. Our mean is still 75, and then our standard our standard deviation is still 10. So basically, let's say we have 75, not 75 students, but an average test score of 75%. So out of all of the kids in a class, the average is 75%. And the standard deviation is still 10. That means about 68% of our students scored between 65 and 85. And then most of the students would fall off right around the middle of that section. And then about 95 would be score between 55 and 95. About 95% of the kids would score between 55 and 95, and only a few would have scored 55 or above 95. All right. So let's go ahead and just kind of wrap this up. So the empirical rule is basically a quick way to estimate how data is spread in a very, very normal way, right? When we have a normal graph like a bell graph, it allows us to explain and figure out what we're doing more fluidly. So I hope that explains the 68, 95, and 99.7% rule. And yeah, I hope I did the math correctly. So, yeah.